Hello everyone, welcome to Sri Vlog's Fun and Edutainment channel. Today we discuss one of the most important topics of M4, that is Unit 1, complex analysis. Okay, so M4 is all deals with complex analysis. Already we discussed in the previous video. In today's video we discuss Unit 1 of M4 and the frequently asked questions of Unit 1 in M4 B.Tech. Okay. M4 Unit 1 complex variable functions. Already you know complex variable in your earlier classes. So always complex variable is denoted by the letter Z, and Z is equal to, generally we take x plus iy. So in this, x is the real part, y is the imaginary part. Okay, so here complex variable functions. In complex variable functions we take the function as w is equal to f of z. It can be expressed as u plus iv, where u is a function in terms of x and y, v is also a function in terms of x and y, and this u is the real part of the function, real part of the complex variable function, v is the imaginary part of the complex variable function. Okay, so first you need to know these things. Okay, when we study complex variable functions, the basic is we can express complex variable function like this: w is equal to f of z, that is equal to u plus iv. U and v are functions in terms of x and y. U is the real part and v is the imaginary part. Now we discuss some important and frequently asked 2 and 3 marks questions in your entrance examination. Okay, let us discuss those questions. Friends, in today's class we discuss these 8 questions which are very important for the entrance examination for 2 or 3 marks, and on these 8 questions there is long answer questions. Okay, long answer questions are also depends on these 8 concepts. Okay, so the questions are here: define analytic function, give an example; define singular point, give example; state necessary and sufficient conditions that f of z to be analytic function; state CR equations in Cartesian system; state CR equations in polar system. When do we say a function is harmonic function? Check whether u equal to x square minus y square is harmonic function or not. Explain how do we find analytic function f of z by exact differential method if u or v given. Explain how do we find analytic function f of z by MT in the sense Milne-Thompson. In short we call it as MT method. MT method if u or v given. Okay, clear? Let's discuss the first question. Define analytic function, give an example. Okay, so see here, a function f of z is said to be analytic at a point z is equal to z0. A function f of z is said to be analytic at a point z is equal to z0 if it is differentiable at z is equal to z0. Okay, here this is the definition of analytic function. A function f of z is said to be analytic at a point z is equal to z0 if it is differentiable at z is equal to 0. That means the function is differentiable at the particular point, then the function is said to be analytic function. Okay, the function is said to be analytic when if the function is differentiable. If the function is differentiable, very important. So analytic means if it is differentiable at the particular point, then it is said to be analytic function. Okay, clear? So if it is differentiable entire domain, then it is said to be analytic entire domain. So some functions are differentiable entire domain of the complex plane. Some functions are not differentiable at some particular points. So if the function is not differentiable at some particular points, then the function is said to be analytic except that particular point. Okay. So this is the concept of analytic function. Now analytic function is also called as holomorphic. Sometimes in your exam, define holomorphic function. The question is also asked. Holomorphic, analytic function only called holomorphic. And monogenic analytic function is also called monogenic function. And also regular function, regular. So these are all synonyms of analytic functions. Holomorphic function is also analytic function, both are equal. Monogenic is also analytic function, regular is also called as analytic function. These are all synonyms. That means in the examination, define holomorphic or define monogenic or define regular, then also this is the only definition. Now example. So all the polynomials are analytic functions. Polynomials in the variable z, because we are discussing complex variable functions. So I am taking f of z is equal, say z square minus 2z plus 3. So clearly it is a polynomial in terms of z, which is the degree 2. Okay, which is having the degree 2. So how do we define degree? The highest power of the variable. You see in this expression, the highest power of the variable is 2. So that it is the second degree polynomial in terms of z. So all polynomials are analytic function. That means all polynomials are differentiable everywhere in the complex domain. Okay, so that this is a analytic function. Okay, clear? Correct. The second one, define singular point. Give example. Okay, a point z is equal to z0 is said to be singular point if it is not analytic at z is equal to z0. Okay, this point is said to be singular point when the function is not analytic at this point. That means analytic means differentiable. That means if it is not differentiable, the function is not differentiable at the particular point, then it is said to be singular point. For example, if we take f of z is equal to 1 by z minus 3. So see here, if we substitute z is equal to 3, the function turns to 1 by 0. That means at z is equal to 3, this function is not defined. If the function is not defined, then it is not differentiable. If it is not differentiable, then it is not analytic. Okay, so when the denominator is equal to 0, the points which the denominator is equal to 0 are always called singular points. Remember that the points which denominator equals to 0 are called singular points. So for example, if we take f of z is equal to 1 by z minus a. So z minus a equals to 0, z is equals to a is the singular point, because the function is not defined at z is equal to a, the function is not differentiable at z is equal to a. That means the function is not analytic at z is equal to a. So this is called singular point. Okay, clear? So the function, a point z is equal to z0 is said to be singular point. If it is not analytic at that particular point, then it is said to be singular point. All the points which denominator are equals to 0 are called singular points. You can give any example of that kind. Okay, right. Now we move to the third one. State necessary and sufficient conditions for f of z to be analytic. So see here, the necessary and sufficient condition for f of z to be analytic are, there are two conditions. Okay, the necessary and sufficient necessary condition and sufficient condition. The necessary and sufficient conditions for f of z to be analytic are: number 1, the first order partial derivatives exist. So here always you have to remember that we take our complex variable function w always in the form, you have to remember this, w is equal to f of z, that is u plus iv. Okay, always we are taking the complex variable function in the form w is equal to f of z, that is equal to u plus iv. Then the necessary and sufficient conditions for this function to be analytic are: the first condition is the first order partial derivatives of u and v. So what are the first order partial derivatives? The partial derivative of u, already you know in your lower classes, partial derivatives are denoted like this: dou by dou x. That means if we do differentiation with respect to one function, other variable treated as constant. That means in partial derivatives there must be two independent variables and one dependent variable. So here u is equal to, in terms of x comma y, u can be expressed in terms of x comma y. So here u is the dependent variable and x comma y are the independent variables. Clear? So if we do the differentiation of u with respect to x, y treated as constant, as well as if we do differentiation of u with respect to y, x treated as constant. You have to keep this in your mind. Okay, right. So here what are the necessary and sufficient conditions? Dou u by dou x, dou u by dou y. U with respect to x, u with respect to y. Dou v by dou x, dou v by dou y. These are exist and continuous. Exist and continuous. The first order partial derivatives of u and v exist and continuous. And the second one is very very important: dou u by dou x equal to dou v by dou y. It should be satisfied. Dou u by dou x, partial derivation of u with respect to x, must be equal to partial derivative of v with respect to y. Okay, so easy to remember: u with respect to x equal to v with respect to y. This is here. And u with respect to y is equal to minus v with respect to x. Dou u by dou y is equal to minus dou v by dou x. Okay, these are the necessary and sufficient conditions for the function f of z to be analytic. And the second one is called CR conditions. CR conditions or CR equations. The necessary and sufficient conditions for a function f of z to be analytic. So remember these two conditions: partial derivatives of u and v, first order partial derivatives of u and v exist and continuous, and dou u by dou x is equal to dou v by dou y. Dou u by dou y is equal to minus dou v by dou x. Second relations are called Cartesian conditions. So this is necessary condition. Okay, right. And we move to the next question. Is state CR equations in Cartesian system. Sometimes the question ask like this in your examination. This is for 2 marks question. Okay, state CR equations in Cartesian system. As we discussed in the previous question, the necessary conditions. What is the necessary condition we have discussed in the previous one? Right, exactly. So if w is equal to f of z, it can be expressed in the form u plus iv. Then the condition, necessary condition in the previous one are the CR conditions or CR equations in Cartesian system. What is the necessary condition? Dou u by dou x, the partial derivative of u with respect to x. Dou u by dou x is equal dou v by dou y. Okay, and dou u by dou y, partial derivative of u with respect to y equal to minus dou v by dou x. Very easy to remember. U with respect to x partially equal to v with respect to y, opposite variable. Okay, u with respect to x. Both are LHS parts. Both LHS parts are in terms of u. This is the first point you remember. Dou u by dou x, dou u by dou y. So dou u by dou x is equal to dou v by dou y, opposite variable. dou u by dou y is equal to opposite sign minus dou v by dou x. These are the CR conditions in Cartesian system. It is asked for to state CR equations in polar system. Polar system. In the previous question, I have discussed Cartesian system. Cartesian system means x comma y. If the coordinate system, if the system consisting of x, y variables, it is called Cartesian system. Here it is polar system. Polar system means the coordinates are in terms of r comma theta. Remember that in polar system coordinates are r comma theta. R comma theta. Clear? Okay. So we have to state CR equations in polar system. So here also our function is f of z is equal to u plus iv, okay, but we have to state in terms of r comma theta. So here first condition is u with respect to r, partial derivative of u with respect to r now, with respect to r, not x, because here polar coordinates means r comma theta. So dou u by dou r is equal to dou v by dou theta, r with respect to, u with respect to r equal to v with respect to theta. Clear? Easy to remember. But here most important point is there is a multiple of 1 by r on the RHS side. 1 by r into dou v by dou theta. It is the first condition. Now B, second one is here u with respect to r and v also with respect to r in second condition. Please remember v with respect to r. Dou v by dou r, not dou u by. Dou v by dou r. U with respect to r as well as v also with respect to r. Now dou v by dou r is equal. So here v with respect to r, that means as simple as that u with respect to theta, it should be equal to dou u by dou theta. And we must get a multiple 1 by r, but it has to be opposite sign. Clear? So dou v by dou r is equal minus 1 by r into dou u by dou theta, as simple as that. Dou u by dou r is equal 1 by r into dou v by dou theta, u with respect to r equal to v with respect to theta with a multiple of 1 by r, and v with respect to r equal to u with respect to theta, v with respect to r equal to u with respect to theta with a multiple of 1 by r but with negative sign. Clear? These are the polar coordinates system, Cauchy-Riemann equations. The Cauchy-Riemann equations in polar coordinates. Clear? So this question is also asked for 2 marks in many times in your examination. Okay? Right. So can you tell what are the Cauchy-Riemann equations in Cartesian system? Just we remind. Yes, dou u by dou x. The difference between polar and Cartesian system is dou u by dou x is equal. In Cartesian system both are in terms of u. Dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. So both are u, LHS parts. RHS parts both are v. So with respect to x, with respect to y equal to, with respect to y, with respect to x equal, and with the opposite sign. So here u with respect to r, v with respect to r, LHS sides. So u with respect to r is equal to v with respect to theta as a multiple of 1 by r. V with respect to r is equal to u with respect to theta as a multiple of minus 1 by r. These are the Cartesian Cauchy-Riemann equations in polar system, right? Yes. Coming to the next question. When do we say a function is harmonic function? Check whether u equal to x square minus y square is harmonic or not. So this question is asked for 3 marks so many times in your examination. Right, let us discuss it now. When do we say a function is harmonic? Harmonic. Remember the word harmonic. Right. So a function phi, any function. Generally we take it as phi or f or u or d. You can take anywhere, any symbol, but generally we take it as phi. A function phi is said to be harmonic function if it satisfies Laplacian equation. Laplacian equation. A function phi is said to be harmonic function. If it satisfies Laplacian equation. What is Laplacian equation? Then you may get a doubt. Laplacian equation is nothing but del square pi equal to 0. Del square pi is the Laplace equation. It satisfies Laplacian equation means del square pi equals to 0. That means a function pi which satisfies the equation del square pi, which is called Laplacian equation, the function pi which satisfies del square pi equal to 0, then the function pi is called harmonic function. Harmonic function. Harmonic function. Now what is meant by this del? Already you studied in your M1, I think. Okay, in vector calculus you studied del square. Del square is nothing but dou square by dou x square plus dou square by dou y square. Del square is nothing but dou square by dou x square. Partial derivative of any function with respect to x twice. Partial differentiation of any function with respect to y twice. The sum of these two values is equal to called del. So this is equal to 0, then it is called a harmonic function. So dou square pi by dou x square plus dou square pi by dou y square is equal to 0. Is equal to 0. Then pi is said to be harmonic function. So when coming to the complex variable function, our complex variable function is like this. W is equal to f of z, that is equal to u plus iv. So if u satisfies this Laplacian equation, then u is said to be harmonic function. V satisfies this Laplacian equation, then V is said to be harmonic function. Okay? So u satisfies Laplacian equation is nothing but dou square u by dou x square plus dou square u by dou y square is equal to 0. Then u is said to be harmonic function. If V, that means dou square v by dou x square plus dou square v by dou y square is equal to 0, then V is said to be harmonic function. Clear? Right. Right here, one more question is there. One more question. What is that? Check whether u is equal to x square minus y square is harmonic or not. Now let us take u is equal to x square minus y square. Just now we have discussed what is harmonic. Harmonic, we have to prove harmonic. Dou square u by dou x square plus dou square u by dou y square is equal to 0. Then u is said to be harmonic function. So that we have to differentiate this u with respect to x partially twice. Now doing dou u by dou x. Dou by dou x of x square minus y square. Already I told you, when doing partial differentiation with respect to one variable, other variable treat as constant. The remaining all the rules are as like as differentiation. Here, so we are doing differentiation with respect to x. So observe here x and x match. Match or not match? Match. So differentiation of x with respect to x. So this x square is not constant. If it is matched, not constant. Okay. What is the differentiation of x square? Right, exactly 2x minus. Now here it is x and we are doing y. We are doing differentiation for y. So is it matched? Here it is x, here it is y, not matched. If it is not matched, that means it is a constant, treated as a constant. So y treated as a constant. So the constant differentiation is 0. So this is equal to 2x. We have to find dou square u by dou x square. That means you have to differentiate one more time for this dou u by dou x. So dou by dou x of dou u by dou x gives us dou square u by dou x square. So dou by dou x of 2x. So dou square u by dou x square is equal to dou by dou x of 2x. 2 is a fixed constant. So when doing differentiation, we take 2 out and we have to do differentiation for x. So 2 into differentiation of x is nothing but 1. So this is equal to 2. Clear? Next we have to do with respect to y. Dou u by dou y. That is dou by dou y of x square minus y square. As like similar process of the dou u by dou x. With respect to y, we are doing so x treated as constant. So dou by dou y of x square is nothing but 0. Y square differentiation exactly 2y. So this is equal to minus 2y. Now once again I have to do differentiation with respect to y. That is dou by dou y of dou u by dou y. That is equal to dou by dou y of minus 2y. So it gives us dou square u by dou y square, that is equal to minus 2 into y differentiation is 1. So that is equal to minus 2. Here, now if you add these two relations, dou square u by dou x square plus dou square u by dou y square, what we get? What is the value of dou square u by dou x square? That is 2. What is the value of dou square u by dou y square? Minus 2. So 2 minus 2, 0. So clearly dou square u by dou x square plus dou square u by dou y square equal to 0. That means u is harmonic function. U is harmonic function. Okay? In this way we can prove harmonic function or not harmonic function. Clear? Next question. Explain how do we find analytic function f of z by exact differential method? There are two methods. The first method is exact differential method. What is the question here? We have to find f of z by using exact differential method. So what is given to us? U or v. So it may be given u or v. Okay, for example, type 1. If u is given, so if u is given, what should we find? F of z. Already we know what is f of z, u plus iv. That means u is already in our hand. So if we want to find, if you find v, then it is easy to find f of z in the form of u plus iv. Okay, that means we have to find v. Now to find v, we have a formula in partial differentiation, that is total differential formula. What is called? Total differential formula. So the total differential formula is nothing but, so clearly observe that here u is given, so that I am taking total differential formula for v. The total differential formula for v is, because v is a function in terms of x and y, observe that v is a function in terms of x and y, so that we can write dv in total differential formula like this: dou v by dou x into dx plus dou v by dou y into dy. Okay, once again I am repeating, dv is equal to v with respect to x partial differentiation into dx plus v with respect to y partial differentiation into dy. This is the step number 1. Step number 1. Step number 2 is we have to find analytic function. So if f of z is analytic function, it should be satisfies Cartesian conditions. So already u is given to us. Then we can find dou u by dou x, dou u by dou y. U is given to us, so we have the values of dou u by dou x and dou u by dou y. So we convert dou v by dou x into dou v by dou x, dou v by dou y in terms of u by using Cauchy-Riemann conditions. Now observe what are Cauchy-Riemann conditions. Clearly we know that dou u by dou x is equal to, once again I am repeating the Cauchy-Riemann equations, dou v by dou y, and dou u by dou y is equal minus dou v by dou x. Clear? So here what we should substitute dou v by dou x. So we take this minus to this side. Dou v by dou y. Okay? How to substitute? Dou v by dou x is there here. So just we transpose this minus to this side, and dou v by dou y is here. We transpose no transpose is here required here. Directly we can substitute in the place of dou v by dou y, dou v by dou x. So the dv changes to, in the place of dou v by dou x, what we can substitute? Minus dou u by dou y into dx, plus in the place of dou v by dou y, what we can substitute? Dou u by dou x. So dou u by dou x, so it is dy. Is dy. Dou v by dou x, no dx. Okay. Dou v by dou y, in the place of dou v by dou y, what we can substitute? Dou u by dou x into dy. Clear? So this is the step number 2. We converted dv in terms of u. So minus dou u by dou y into dx plus dou u by dou y into dx. Now this dv can be expressed as total. Consider this minus dou u by dou y as capital M dx. Total dou u by dou x as capital N dy. You can written this as m dx plus m dy. So if it is exact, there is a condition. Once again I am repeating, the condition for this equation is to be exact is dou m by dou y is equal dou n by dou x. Dou n by dou x. That means we have to differentiate m with respect to y and n with respect to x. What is m? Minus dou u by dou y. So that means minus dou square u by dou y square. That is equal, what is n? Dou u by dou x. Again we are differentiating with respect to dou by dou x. So in the place of n, it is there. In the place of n, it is there. So dou by dou n means dou square u by dou x square. So dou square u by dou x square plus dou square u by dou y square is equal to 0. That means u is a harmonic function. If u is a harmonic function, dou square u by dou x square plus dou square u by dou y square equal to 0. That means this is exact differential. So it satisfies. U is a harmonic function. That means we already know that dou square u by dou x square plus dou square u by dou y square is equal to 0. Here, that means always m dx plus m dy is exact differential. So no need of checking this condition, because if it is analytic, it is harmonic. If it is analytic, it is obviously harmonic. Okay? Dou square u by dou x square plus dou square u by dou y square is equal to 0. So no need of checking this condition, but for your understanding, I explained this. Okay? Now I have to find v. So if it is exact differential equation, we have a formula in your M1, M2, exact differential equation. So the formula to find v is by doing integration on both sides. You have to do the integration on both sides. So v is equal to integral m dx 3 y constant plus integration of n dy not contain x terms. So this is the formula. So we are doing the integration, so we have to add a constant. So in this way we can find v. Okay? So this is the step number 3. Step number 3. So we found v. Now our aim is to find f of z. So how do we write now f of z? Already u is in our hand. Already given u. Okay? We found v in this way by using exact differential method. So u plus iv, you can write f of z is equal. You can find f of z is equal to u plus iv. Writing u and v in this expression, you can find f of z. Clear, completed. But sometimes it may ask that find f of z in terms of z. When it is asked in terms of z, you have to write in this expression where you get x, you have to write z, and in the place of y, you have to write 0. If you write in the place of x is equal to z, y equal to 0, you get f of z in terms of z. So initially you get f of z in terms of x and y in this method. But finally if you write x is equal to z, y is equal to 0 in this equation 1, f of z, then you get f of z in terms of z. Okay? Clear? So this is the way of finding f of z in the exact differential method. Step number 1 is you have to take dv is equal to dou v by dou x into dx plus dou v by dou y into dy. Applying Cartesian conditions, we get dv as minus dou u by dou y into dx plus dou u by dou x into dy. Now comparing with it m dx plus m dy, it is always harmonic function because it is analytic function, so it is a harmonic function. So no need of checking. It is obviously exact differential. So if it is exact differential, we have the formula for integration. To get v value, v is equal to integral m dx, treat by constant plus integral m dy, so not contain x terms plus some constant. So in this way you can find v, and at last you have to write v value in f of z, given v value in f of z is equal to v plus iv. Sometimes it may ask that find f of z in terms of z, then you have to substitute x is equal to z, y is equal to 0. Clear? Explain how to find f of z using Milne-Thompson. MT is nothing but Milne-Thompson method. If u or v is given, that means if real part is given or imaginary part is given. So if we know real part is given, then the same process we can apply to the imaginary part also. In the previous one is also same. If we know how to find v, if u is given, the similar process can be applied for v is given and how to find u. Okay, right. Now here already we know our complex variable function is of the form w is equal to f of z, that is equal to u plus iv. It is in the form of u plus iv. Here very important is you can write f dash z. We can find directly f of z here. Okay. You can find directly f of z. No need of finding v alone or no need of finding u alone. So just we observe what is given, u or v, that is we have to keep in our mind. Now f dash z is equal, you clearly know that dou u by dou x plus I into dou v by dou x. It is our f of f dash z. Take it as equation number 1. Okay, you can take it as with respect to y or with respect to x. Just I am taking with respect to x. F dash z is equal to dou u by dou x plus I into dou v by dou x. Now observe that what is given. It is very important. What is given? U is given. Just we assume that u is given. So step number 1. If u is given, u is given. That means what is in our hand? U is in our hand. That means we can find dou u by dou x. Dou u by dou x value is our hand. So no need of change this. What should we change? Dou v by dou x. How do we change? Because it is analytic function. Because it is analytic function. How to find analytic here? Please write that. Analytic. Because it is analytic, it satisfies CR conditions. So according to CR conditions, what we know? Dou u by dou y is equal minus dou v by dou x from CR equations. Clear? From CR equations, we know that dou u by dou y is equal to minus dou v by dou x. So we substitute in the place of dou u by dou v by dou x minus dou u by dou y. Okay, what is there here? Dou v by dou x is there. So in the place of dou v by dou x, we can replace minus dou u by dou x. So that f dash z changes like this. Dou u by dou x remains the same, minus I into dou u by dou y. Clear? Now what Milne-Thompson stated? This is the Milne-Thompson stated. This is Milne-Thompson stated. So after finding dou u by dou x, you have to substitute in the place of x z, in the place of y 0. So f dash z is equal to dou u by dou x at z comma 0 minus I into dou u by dou y at z comma 0. That means in the place of x, in dou u by dou x, you have to substitute in the place of x z, in the place of y 0. Same, dou u by dou y in the place of x z, in the place of y 0. Then doing the integration on both sides. Doing the integration on both sides. So integral f dash z. So integration and differentiation cancel. We get directly f of z. F of z is equal to integration of dou u by dou x at z comma 0 into dz minus I into integration of dou u by dou y at z comma 0 into dz. So after completion of integration, you have to add a constant. While doing the indefinite integration, you have to add a constant. So this is about Milne-Thompson method of finding f. If u is given, sometimes if v is given, same process you can do. So if v is given, just you convert f dash z in terms of v only, because v remains the same. In the place of dou u by dou x, what you can substitute? Dou v by dou y, clear? So dou v by dou y plus I into dou v by dou x. Again you have to replace both sides. In the place of dou v by dou y, in the place of x z, y 0, and integrating on both sides, you get integral dou v by dou y of z comma 0 into dz plus I into dou v by dou x of z comma 0 into v is given. Clear? So this is the Milne-Thompson method of finding analytic function of object. Clear? So I hope all you understand these 8 questions. So these questions are frequently asked 2 marks or 3 marks in your end sem examination. Very, very important questions, and it depends on these concepts. You can do the long answer questions also. Okay, so these are very, very important. Okay, so I hope all you understand these concepts. Thank you very much. If you like my video, please like, share and subscribe to my channel. Thank you all. Signing off, Sridhar.